Find the values of t for which the matrix with entries 2 minus t, 6, 2, 2t plus 7 is singular. We take down solution. We have the matrix A, the entries A, B, C, D. The determinant of the matrix A is given by A times D minus B times C. The matrix A is singular if the determinant of the matrix A is equal to 0. That is, if we take AD minus BC and it is equal to 0, then this matrix A is said to be a singular matrix. We have to find a value of t for which this matrix is singular. So for this matrix to be singular, that means the determinant must be equal to 0. That means we are going to equate this to 0. We equate 2 minus t, the determinant, to 6, 2t plus 7. We equate this determinant to 0. For us to get the determinant, we take the product of the entries on the leading diagonal minus the product of the entries on the alternate diagonal. That is, take 2 minus t times 2t plus 7 minus 2 times 6. We equate this to 0. We have to expand these two brackets. 2 times 2t gives us 4t. 2 times 7 gives us plus 14. Negative t times 2t gives us negative 2t squared. Negative t times 7 gives us negative 7t minus 2 times 6 gives us 12. We equate this to 0. This will give us negative 2t squared. 4t minus 7t gives us negative 3t. 14 minus 12 gives us 2. We equate this to 0. Next, we are going to make the coefficient of t squared to be positive. That is, we are going to multiply all through this equation by negative 1. Negative 1 times negative 2t squared minus 3t plus 2 is equal to negative 1 times 0. Negative 1 times negative 2t squared gives us 2t squared. Negative 1 times negative 3t gives us plus 3t. Negative 1 times 2 gives us negative 2. We equate this to negative 1 times 0, which is 0. This is a quadratic equation which we have to solve for t. For us to solve this quadratic equation, we are going to make use of the method of factorization. We need two numbers such that their sum is equal to the coefficient of t, which is 3, and their product is equal to 2 times negative 2, which is negative 4. The two numbers, they are simply 4 and negative 1. 4 plus negative 1 is the same as 4 minus 1 gives 3. 4 times negative 1 gives us negative 4. This will give us 2t squared plus, we are going to replace 3 with 4 minus 1. We multiply this by t, minus 2 is equal to 0. This will give us 2t squared plus, we have to expand this bracket, 4 times t gives us 4t, negative 1 times t gives us negative t, minus 2 is equal to 0. Next, we have to factorize. We take the first pair, we factorize. We take the second pair, we factorize. For the first pair, 2t is common. 2t times t gives us 2t squared plus 2t times 2 gives us 4t. For the second pair, -1 is common. Factor -1 times t gives us -t. -1 times 2 gives us -2. We equate this to 0. We have two terms. The two terms we have t plus 2 is common. We are going to factor out t plus 2 times 2t minus 1. We equate this to 0. For this product to be equal to 0, either t plus 2 is equal to 0 or 2t minus 1 is equal to 0. Either t plus 2 is equal to 0 or 2t minus 1 is equal to 0. We have to solve for t. If we take the first one, t plus 2 equal to 0, this is a linear equation, then t will simply be equal to -2. If we take the second one, 2 star, 2t minus 1 equal to 0, then 2t will be equal to 1. Then if we divide both sides by the coefficient of t, which is 2, 2t divided by 2 is equal to 1 over 2. This will imply that t will be equal to a half. These are the two values for t. Then we conclude, therefore, t is equal to -2 or t is equal to a half. These are the two values of t for which this matrix is a singular matrix. We are done with the solution of this question. If in case you have any worries, feel free to drop your questions at the comment section. Please like the video, share, and subscribe to this channel. Thank you very much for watching.